Type TC cable is not explicitly permitted or prohibited for use in docks according to the National Electrical Code. However, the NEC does specify that electrical equipment in wet or damp locations must be suitable for the location, referenced in Article 110.11. Conductors and equipment in contact with or exposed to seawater must be protected against corrosion, as highlighted in Article 110.17. Type TC cable is resistant to moisture and corrosion, but it is not designed for direct immersion in water. The sheath is not waterproof and could allow water to penetrate and damage the conductors. In a dock environment, the cable would be subject to regular wetting from rain, snow, and boat wakes, possible submergence during storms or high tides, and contact with corrosive salt water. For electrical installations in docks, it is recommended to use firstly, marine-grade electrical equipment designed to withstand harsh marine conditions, secondly, conduit to protect conductors from damage and moisture, thirdly, corrosion-resistant fasteners and fittings, and fourthly, ground fault circuit interrupters, or GFCIs, to prevent electric shock. While Type TC cable may provide some protection against moisture, it is not suitable for direct exposure to seawater or other wet or corrosive environments in docks. For code compliance and safety, it is strongly recommended to use marine-grade electrical equipment and conduit to protect conductors in dock applications. Understanding suitable alternatives for electrical installations in docks involves recognizing the limitations of standard cables like Type TC in harsh marine environments. Let's delve deeper into the recommended practices and code considerations for ensuring safe and compliant electrical systems on docks. Firstly, marine-grade electrical equipment is specifically designed to withstand the corrosive effects of salt water and the constant exposure to moisture. This equipment typically includes features such as waterproof enclosures, corrosion-resistant materials, and robust construction to ensure long-term reliability. Secondly, the use of conduit provides an additional layer of protection for electrical conductors, shielding them from physical damage and moisture intrusion. Conduit can be made of various materials, including PVC, galvanized steel, and aluminum, each offering different levels of corrosion resistance and mechanical strength. Thirdly, corrosion-resistant fasteners and fittings are essential for maintaining the integrity of electrical connections in marine environments. These components are typically made of stainless steel, bronze, or other non-corrosive materials to prevent rust and deterioration, ensuring reliable electrical performance over time. Fourthly, ground fault circuit interrupters, or GFCIs, are critical safety devices that protect against electric shock by detecting ground faults and quickly interrupting the circuit. GFCIs are particularly important in wet environments like docks, where the risk of electric shock is significantly higher. When selecting marine-grade electrical equipment, it's important to consider the specific environmental conditions of the dock and choose products that are rated for those conditions. For example, equipment that is intended for use in submerged areas should be waterproof and resistant to prolonged exposure to salt water. Similarly, conduit should be selected based on its ability to withstand the corrosive effect of the marine environment and provide adequate physical protection for the conductors. In addition to using marine-grade equipment and conduit, it's also important to follow proper installation practices to ensure the long-term reliability and safety of electrical systems on docks. This includes using appropriate wiring methods, making secure connections, and providing adequate support for cables and conduits. Regular inspections and maintenance are also essential for identifying and addressing potential problems before they lead to electrical hazards. This includes checking for signs of corrosion, damage, or wear on electrical equipment, as well as testing GFCIs to ensure they are functioning properly. By following these recommended practices and code considerations, you can ensure that electrical systems on docks are safe, reliable, and compliant with applicable regulations. This not only protects people and property from electrical hazards, but also helps to maintain the long-term value and functionality of the dock. Understanding the specific requirements for electrical installations in marine environments is crucial for ensuring the safety and longevity of these systems. The NEC provides detailed guidelines for electrical work in various locations, including docks and marinas, and it's important to be familiar with these requirements to ensure compliance. In addition to the NEC, local codes and regulations may also apply to electrical installations on docks, so it's important to check with local authorities to determine the specific requirements in your area. By staying informed about applicable codes and regulations and following recommended practices, you can help to ensure that electrical systems on docks are installed and maintained in a safe and compliant manner. This not only protects people and property from electrical hazards, but also helps to avoid costly fines and penalties. In summary, while Type-C cable may offer some degree of moisture resistance, it's not a suitable choice for direct exposure to seawater or other wet or corrosive environments on docks. Instead, it's recommended to use marine-grade electrical equipment, conduit, corrosion-resistant fasteners and fittings, and GFCIs to ensure the safety and reliability of electrical systems in these challenging environments. By following these recommendations and adhering to applicable codes and regulations, you can help to create a safe and compliant electrical system on your dock. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installations are properly designed and installed to meet your specific needs and requirements. Electrical safety is paramount, especially in marine environments where the risk of electric shock is heightened. Taking the necessary precautions and using appropriate materials and equipment can significantly reduce the risk of electrical hazards and ensure the safety of people and property on docks. Now let's delve into the specific types of marine-grade electrical equipment that are recommended for dock installations. Firstly, marine-grade wiring is designed with tinned copper conductors to resist corrosion from saltwater exposure. The insulation is also formulated to withstand a harsh marine environment, including UV radiation and temperature fluctuations. Secondly, marine-grade circuit breakers and fuses are enclosed in waterproof housings to protect them from moisture and corrosion. These devices are designed to interrupt electrical circuits in the event of an overload or short circuit, preventing damage to equipment and reducing the risk of fire. Thirdly, marine-grade lighting fixtures are designed to withstand the corrosive effects of saltwater and the constant exposure to moisture. These fixtures are typically made of stainless steel, bronze, or other non-corrosive materials and are equipped with waterproof seals to prevent water intrusion. Fourthly, marine-grade receptacles and switches are designed with waterproof covers and corrosion-resistant contacts to ensure reliable electrical connections in wet environments. These devices are typically made of durable materials that can withstand the rigors of marine use. When selecting marine-grade electrical equipment, it's important to choose products that are certified by recognized testing laboratories such as Underwriters Laboratories, or AL, or American Boat and Yacht Council, or ABIC. These certifications indicate that the equipment has been tested and meets applicable safety standards. In addition to selecting appropriate equipment, it's also important to follow proper installation practices to ensure the long-term reliability and safety of electrical systems on docks. This includes using waterproof connectors and fittings, providing adequate support for cables and conduits, and grounding all electrical equipment to prevent electric shock. Regular inspections and maintenance are also essential for identifying and addressing potential problems before they lead to electrical hazards. This includes checking for signs of corrosion, damage, or wear on electrical equipment, as well as testing GFCIs to ensure they are functioning properly. By following these recommendations and adhering to applicable codes and regulations, you can help to ensure that electrical systems on docks are safe, reliable, and compliant. This not only protects people and property from electrical hazards, but also helps to maintain the long-term value and functionality of the dock. Furthermore, it's crucial to understand the grounding and bonding requirements for electrical systems on docks. Grounding refers to the connection of electrical equipment to the earth, providing a path for fault current to flow back to the source and tripping the circuit breaker or fuse. Bonding refers to the connection of non-current carrying metal parts of electrical equipment to each other, creating a low impedance path for fault current to flow. In marine environments, grounding and bonding are particularly important because they help to prevent electric shock hazards caused by stray currents in the water. The NEC provides specific requirements for grounding and bonding electrical systems on docks, including the use of a grounding electrode system that is connected to the earth and the bonding of all metal parts of the electrical system. It's important to follow these requirements carefully to ensure the safety of people and property on docks. In addition to grounding and bonding, it's also important to consider the use of surge protection devices to protect electrical equipment from voltage spikes caused by lightning or other electrical disturbances. Surge protection devices, or SPDs, are designed to divert excess voltage away from sensitive electronic equipment, preventing damage and reducing the risk of fire. SPD are particularly important for protecting expensive electronic equipment such as computers, televisions, and stereos from damage caused by voltage surges. When selecting SPD, it's important to choose products that are rated for the voltage and current levels of the electrical system and that are installed in accordance with the manufacturer's instructions. By implementing proper grounding, bonding, and surge protection measures, you can significantly reduce the risk of electrical hazards and protect electrical equipment from damage on docks. Remember to consult with a qualified electrician or electrical engineer to ensure that your electrical installations are properly designed and installed to meet your specific needs and requirements. Electrical safety is a shared responsibility, and by taking the necessary precautions and following recommended practices, we can help to create a safer environment for everyone on docks. In conclusion, when it comes to electrical installations on docks, safety and compliance should always be the top priorities. While Type TC cable may offer some level of moisture resistance, it's not a suitable substitute for marine-grade electrical equipment and proper installation practices. By using marine-grade equipment, conduit, corrosion-resistant fasteners and fittings, GFCIs, and surge protection devices, and by following applicable codes and regulations, you can help to ensure that electrical systems on docks are safe, reliable, and compliant. Don't take shortcuts or compromise on safety when it comes to electrical installations in marine environments. Always consult with qualified professionals and follow recommended practices to protect people and property from electrical hazards. Electrical safety is an ongoing process that requires diligence, attention to detail, and a commitment to following best practices. By staying informed, taking precautions, and seeking professional guidance when needed, we can all contribute to creating a safer environment for everyone on docks.